Continuing along with B. If you look at B, I would ask you, what would you do with something like this? We've got a binomial times another binomial, which means 2 terms times 2 terms. Without hesitation, you'd probably say, oh, this was either distributing or FOIL. It means the same thing. That's exactly what we're going to be doing here, even though you see i's. We're just going to be FOILing. So we'll start out with a 3 minus 2i times a 4 minus 3i. So to FOIL this out, we'd start by multiplying out the 3 first. The 3 times the 4 will get us a 12. Then the 3 times a negative 3i will get us a negative 9i. Then the negative 2i times the 4 will get us a negative 8i. And the negative 2i times a negative 3i will get us a positive 6i squared. And let's see, continuing right along, same thing that we would do normally after FOILing would be combine our like terms. We've got a negative 9i and a negative 8i. Those can get added up and will become a negative 17i. We still have our positive 12 that can get brought down. The other difference here is we can leave that plus 6, but I want to replace that I squared, just like all of these, with a negative 1. So that means I actually have to do some math here. 6 times negative 1 is going to give us a negative 6 for this piece. Well, what's interesting then is that we end up with another set of like terms. That is something that doesn't normally happen with x's, but does happen with the i's here. Is now I have a 12 minus a 6. Well, 12 minus 6, they're like terms. I can just subtract normally, is just a positive 6. I still have my negative 17i. And notice I did make sure that I put the normal number first and the I at the end because I want it in that A plus BI form. So be careful about that. But this is my final answer, 6 minus 17i. And that's what I would want to enter in as my final answer into my math lab. Continuing along, let's take a look at C. In C, we've got 5 plus the square root of 3 and then the i's on the outside. As a reminder, if you're not sure, I should never be on the inside of a square root because the reason why we have i's is because negatives came out of a square root and turned into an I. So I always do this like little line at the end of my square roots so I don't accidentally think that the i's are inside. Or you can actually just rewrite it as 5 plus and put the I out in front of the square root. To me, that's what I would normally do, just so I don't get confused on both of them, but it's up to you. I'm going to do it the way the book would do it and leave the I at the end, but I think it's confusing. So if you decide to on your tests and your homework and stuff, put the I's out in front like I did here, absolutely, that is fine, and I agree with you. So, but we've got 5 plus the square root of 3i times 2 minus the square root of 3i. And again, I'm going to make sure I close off my square root. I'm going to be FOILing again. Same exact idea. So I'm going to multiply out my 5 times my 2 first, which is 10. Then my 5 times my negative square root of 3i. What's funny is whatever's outside the square root stays outside, whatever's inside stays inside, and nothing mixes and matches. So I do have a negative here, so that will be negative. I do have a 5 that's outside, so I'll have the 5 that's outside. I have a square root of 3 that's inside, so that'll stay inside. I'm going to close that off. And I have an I that's outside, that will stay outside. So it looks funny, but that's exactly how it's going to work. Nothing crazy here. Then the next piece we'll do a positive square root of 3i times the 2. So that'll be a plus because of the positive, or plus. We also have a 2 that we're picking up that's outside. We also have a square root of 3 that we're picking up. And we also have an I that we're picking up here. Last little piece that we should be picking up when we're foiling here is we should be taking the square root of 3i times the negative square root of 3i. Well, the first thing, we had a positive times a negative now, which is going to give us a negative. I'm going to be a little bit careful here. We also have a square root of 3 times the square root of 3. Well, they're both underneath the square root. What happens when you multiply two identical square roots? The square roots cancel out, leaving you with the number, so we'll just have the 3. However, we also have an I times an I, which is also going to give us an I squared. Now, this looks like a huge mess, but it's not going to be a huge deal. Because, just like before, notice these middle terms here. They look pretty awful, but notice they both match up. They both have a square root of 3 and an I. So they're like terms. Well, we've got a negative 5 and a positive 2. Well, negative 5 added to positive 2 is a negative 3. Negative 3 what's? Well, we have to leave the matching part, the square root of 3i, the same. That's it. However, I'm going to bring down my little numerical term at the beginning, the 10. And I did have a negative 3. The only other thing I want to swap out is that this I squared is a negative 1. So far, so good. I replaced that the I squared was a negative 1. That lets me do one extra thing now, is that a negative 3 times a negative 1 is now going to turn into a positive 3, which, just like the last one, gives me a new set of like terms. So we have now a positive 10 and a positive 3, which is now going to give me a positive 13. When I add those two like terms, I still need to bring down my negative 3 square roots of 3i. Now, I know it's tempting to want to subtract the 13 and the 3, but you can't because they're not like terms, because that second piece has an I and a square root of 3. They are not like terms. So you really need to leave it like this, the 13 minus 3 square roots of 3i. That's your final answer. Now let's take a look at D. In D, we've got 3 minus 2i squared. Well, the question is, what does it mean for something to be squared? Remember, squared means that there's 2 of something, which means we've got identical twins. So I'm going to have a 3 minus 2i, twins, so times another 3 minus 2i. Nothing changes, identical copies, twins. It's always what I think of when I see that little squared. Now I need to FOIL like I was doing before, so let's multiply out our 3 first, which will give us 9 minus 6i. That'll at least get me started with my FOILing. My second part of FOILing means I need to multiply out the negative 2, which will get me another negative 6i, and negative 2i times another negative 2i will get me a positive 4i squared. I'm getting there and getting a little bit better at this, so let's see. Now I can go ahead and combine like terms in the middle. I've got a negative 6i and a negative 6i. When those get added up, that will give me a negative 12i. I can carry down my 9. And let's see, what else can I do? I also have an I squared here that can get replaced with a negative 1. So I'll leave my 4, but I can replace my I squared with a negative 1. And then I can do my math there, that I've got a, what do I have here? I have a 4 times a negative 1, which is negative 4. So let's see what that gives me. Now I've got a 9 minus a 4, which will give me a positive 5. And don't forget, I did have this negative 12i, and notice I did make sure that I put my I second, because remember, they always want the I at the end, but that is my final answer. So all these concepts in this section of multiplying and adding, they're all things that we've done before. It's just little slight modifications because the i's act a tiny bit different than x's. Let's take a look at E. In E, we have I times 2 plus 7i times 2 minus 7i. So let's see what happens here. This means we're actually multiplying 3 things here, but you have to do 2 things at a time. If you try to do more than that, it gets a little confusing. So I'd start by saying, well, I need to multiply out the I. Be careful that you only multiply out the I once. So you start at the beginning of the parentheses and distribute, and you stop when the parentheses stop. That's the way I remember it. So let's multiply out that I, and that will give me a 2i plus a 7i squared. That second piece does not get multiplied by the I. Now what? Well, before we go any further, there is something I can do, is that remember this I squared is a negative 1. So what will that do? So if I replace that I squared with a negative 1, what that will do is turn this positive 7 here into a negative 7. So let's go ahead and do that. That will help us along the way if we do any math we can that we run into. So we said it would turn into a negative 7. Everything else will stay the same. Now I'm just down to a problem like I was doing a minute ago where I'm just foiling. So let's work on just the regular foiling because we're just dealing with one thing at a time so we don't get overwhelmed. So multiplying out the 2i to everything on the inside will get me, let's see, a 4i minus 14i. Then I also need to distribute out a negative 7, which will get me a negative 14. Times a negative will give me now a positive 49i. Oops, and I see I made a small mistake here. Let's see, when we did the 2 times the 2i times the 2, I did get a 4i, and when I did the 2i times the negative 7i, I should have gotten a negative 14i squared. Be careful. Okay, now I can combine my like terms. Well, let's see, what are my like terms? I have a 4i and a 49i, which will add up to become a 53i, and that's a positive 53i. So that will get me started. I also have, let's see, the negative 14, but it has an I squared attached to it. So I'm going to replace that I squared with a negative 1. And I also have this negative 14 that I'm going to drag down that I'm not going to touch yet. Well, notice when I replace my I squared with the negative 1 here, is that what happens is I get a negative 14 times a negative 1, which will actually turn into a positive 14. So what this now gives me is a positive 14. Well, notice then I've got a negative 14 and a positive 14. Those will just cancel out because they're opposites. So the only thing that's actually left here out of all of this is just my positive 53i. So that's my final answer, is actually just the positive 53i. Let's take a look at